Okay guys, as you can see, this is video number 2. It'll go a little quicker on this one. What I do notice about the first equation over here is y equals 7 minus x. So it's going to be pretty easy in that case if we just come up with a couple of points. Like, what if x equals 0? If x would equal 0, then we'd have 7 minus 0 for y. That gives me an easy point to graph. 3, 4, 5, 6, 7. There's 0, 7 right there. Now, what if x happens to be something else? Just pick another number. Maybe x is like 4. Well, you could easily figure out what 7 minus 4 is. That's 3. So you could go ahead and plot the point 4, 3 as well. And when you have those 2 points plotted, that is going to be enough to make a graph of that line. And you can see that that's going to end up being a -1 for a slope. So if you wanted more points because you feel more comfortable with doing that, then this would be a good thing to be able to do. That's good. If you want to look at what's going to be happening after that, well, that's a mistouch on the screen right there, but don't worry about that. Here's what we would end up with, and we would have something that would hit very nicely on all those points. And there's an example of the first graph. The second one's a little bit more difficult, but we can still do some of the same ideas. Like, for instance, if y was 0 in this case, if y happens to be 0, then x would just be 11. And that's the easiest one to graph probably. Let me get rid of that little line right there if I can. And if I can graph the point 11, 0 and make that work out for us, that would be good. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would be right here. That is 1 point on my graph. Now you can make x and y be whatever you want and just figure out what the other one is. I kind of like the idea of picking a number for y and figure out what x would have to be in this case, because there's a number in front of y and that's going to make it easier. For instance, what if we said that y had to equal 3 right here? Just to get another point on the graph. If y has to equal 3, we could say x plus 3 times 3 equals 11. And we could say x plus 9 equals 11. And using the equality properties, we can get x equals 2. So if x is 2, y's got to be 3. And that's another point that's on this line. The reason I like that point is I can see where if I connect those two last final dots that I made, I'm going to have these things be able to cross, which means they have a common solution, like we saw on the MDC test together. And we can see where those things cross. This does illustrate a little bit of one of the problems that we have with solving by graphing. You can't tell exactly where things are sometimes, but I think we did a good enough job on this one that we could go ahead and count and figure out what that point is. And I think in this case, it's going to be 5, 2. But since I had to use those phrases like I think it is or it's probably, it would be a better idea to check this algebraically. For instance, if x is 5 and y is 2, does it make the first equation true? And we can check that by just throwing it back in there. Yep, 2 equals 7 minus 5. Does 2, did that wrong, so does 5 plus 3 times 2 equal 11? Well, that's going to be 5 plus 6, so yes it does. And now we have that one. So there's a variety of other ways to do it, but I feel like this is probably the easiest way to see that one and be done.